All right, in this video, I'm gonna break down how to solve quadratics. All of these quadratics are written in the form of ax squared plus c. And when you have those set up like this, you can solve them algebraically by using inverse operations, just like when you did your two-step and your multi-step equations. The last thing we're gonna get rid of is the exponent of 2 in all three of these examples. Let's go through each one of them so you see 3, and then you can do them on your own once you're done with this video. So I always tell my students, split the left and the right side up. Just like if it was a two-step equation, we need to get rid of this constant of negative 371. So we're gonna inverse operate and add 371 to both sides. That's gonna remove that term. We add 371 to 29, which is gonna give me a nice, neat 400. And then over here, I still have my 4x squared. Now the next step, just like it would be if it was a linear equation without the exponent of 2, we need to get rid of the 4, the coefficient attached to the variable. Well, 4 and x side by side means multiplication, so the inverse operation is division. Divide by 4, cancels it out, divide by 4, and now we have x squared equals 100. Now, because 100 is a perfect square, you probably already know what x is, but let me show you how to get rid of the exponent so that we can get x isolated all by itself, and we know exactly what number it should be. Opposite of squaring something is square rooting it. So just like the opposite of subtracting 371 is adding 371, that's how we eliminate things. The opposite of squaring is square rooting, and that's canceled out now. Now, if I'm going to square root on the left side, I got to remember to square root on the right side. So we just determine what's the square root of 100, which we should know by now is 10. So x would have to be 10 to make this equation true. All right, let's do it now with this problem where we don't get such a nice number to root. So we got 4x squared plus 10 plus 1, or excuse me, plus 11. So opposite of adding 10, I'm going to subtract 10. That's going to cancel that term out. Take 10 away from 11. That leaves me with just 1. So now I've got 4x squared equals 1. I got to get rid of the 4 the same way I did over here. We're going to divide by 4. Opposite of multiplying 4 and x is dividing by the 4. Divide by 4 over here. Cancels out. Now I've got x squared equals 1/4. 1/4. Remind yourself, how do I get rid of that exponent of 2? Opposite of squaring is square rooting. Cancels it out. Now when you square root a fraction like we look at over here, 1/4, this is the same as x equals the square root of 1 over the square root of 4. So you just root the top and the bottom. Numerator has to get the square root of it. Denominator has to also get the square root of it. So the square root of 1 is 1. X is equal to 1 over, what's the square root of 4? 2. So our answer is going to be x equals 1/2. Now, one thing I forgot to mention is that when we are square rooting a value, we actually have two answers, right? Two answers. It's going to be 10 or negative 10. Sorry, I forgot about that. Okay. So we got to include both of those answers because negative 10 times itself would also make 100. A negative times a negative makes a positive. So let's go back over here. If we're saying x is 1/2, it could be 1/2 or negative 1/2. You want to give the positive and negative of that value. Okay, last one, probably the more difficult of them all. 9x squared minus 35 equals 14. So what we're going to have to do is get rid of the 35. Then we want to get rid of the 9. Then we want to get rid of the exponent in that order. So what's the opposite of subtracting 35? Yes, adding 35. Cancels, gone. Add 35 to 14, leaving me with 49. I like that number 49 right away because I know it's a perfect square. 9x squared, but it doesn't really matter because we've got to divide by 9 to get rid of the 9 next. So it's going to take that perfect square away from us. What's 49 divided by 9? 49 divided by 9. Actually, I don't know what that is. Let's use a calculator real quick. 49 divided by 9 equals 5.4 repeating. 5.4 repeating equals x squared. Okay, now I got to take the square root of both sides. So I'm going to root 5.4 repeating. Square root, cancels the exponent away. X is equal to whatever the square root of 5.44444 for eternity is. So let's just type that in. Square root of 5 point, I usually go to the end of my calculator with my decimals like that. Put that parenthesis in, and I get 2.3 repeating, 2.3 repeating. So you can answer this two different ways. You could say positive and negative 2.3 repeating, or you could turn that into a fraction, which would be positive and the negative of 7/3. Either of those answers are acceptable. If you're asked to give it in decimal form, 2.3 repeating. If you're asked to give it as a fraction, 7/3 is the same as 2.3. Hopefully this makes sense. Sorry, 2.3 repeating. Okay, hopefully this makes sense. Remember, positive and negative with every single one of these, because square roots have both a positive and a negative result. Get rid of the constant first, get rid of the coefficient next, then get rid of the exponent in that order. Study hard and good luck on your upcoming test.